Good morning to all of you. Today I am going to discuss sums on permutation and combination models, which is called as combinatorics. Already I have discussed 4 previous videos in which we have discussed probability different models. Now I am going for permutation and combination model. First of all, we should know what is meant by permutation. Permutation is nothing but arrangement of a set of objects. Now there are thousands of objects, but we have to arrange them according to a given order. That is called as permutation. Now coming to combination is arrangement of a set of objects where there is no particular order. We can arrange them as we like, whereas coming to the permutation, we need to arrange a set of objects which are having a proper order. So arrangement of set of objects or members in a particular order is called as permutation. Where is this permutation used in daily life? Permutation is used in sorting and analyzing algorithms in computer science. In mathematics, it is used in various places, in various topics. In quantum physics, also it is used in identifying the state of the particles. It is also used in describing the state of particles in biology, especially RNA. And also permutation is important in counting in mathematics, important in order. Now, simple and basic permutation. Suppose there are 5 different boxes which are different colors, say red, green, pink, and yellow. Now, total number of boxes is called as capital and is 5. And how many we are going to select, how many we are going to arrange is called, or how many we are going to take is 3 at a time in this question. So the 3 is small n. Now coming to the permutation formula, n factorial by n minus small n factorial. There is no much difference between permutation and combination. Combination is nothing but selecting objects, but there is no order for that, whereas permutation we need a particular set of order. Combination also we have the same formula, n factorial by n minus n whole factorial into small n factorial. This is the formula for combination, that is nothing but n factorial by n factorial bracket n factorial. Now if you see this case, in permutation there are 5 different objects. Capital is called 5 by 5 minus 3 is that is nothing but 2 factorial. I'm sorry. Now coming to the second, that is 5 factorial by 2 factorial is 120 by 2, that is 60. So 5 objects can be arranged in 60 different ways. Coming to the combination, 5 factorial by 3 factorial into 5 minus 3 factorial, that is nothing but 10. So a sequence of numbers to open a lock is an example of a combination. So there's a difference in permutation and combination. Now we are going to discuss only about permutation, different models, then we are going for the combination. What is combination? Let me just explain. Combination is a selection of objects without any order. For example, we have a set of 3 alphabets A, B, and C. The question is, letters in each possible selection is an example of the combination. That means we are having 3 ABC different letters, and each combination, each possible selection, that means ABC, ACB, BAC, BCA, CAB, BA, 6 different possible combinations. Example for combination. Let's go for permutation now. Permutation non-circular, that means non-circular means it's linear straight. How many different, question number 1, how many different ways 3-digit numbers can be formed? So 3-digit numbers in the sense we get 100, 101, 102 up to 999, but that is not the question. How many different ways 3-digit numbers can be formed such that the digits are distinct prime numbers? The digits are distinct prime numbers. Now coming to the prime number section, we have 2, 3, 5, and 7. We have 4 different prime numbers, 2, 3, 5, and 7. And 9 is not a prime number, as 9 can be written as 3 cross 3. Now we have to arrange these 4 prime numbers into 3-digit numbers, and the 4 must be different prime numbers. We should not use the number 2 again and again. Repetition is not allowed. All are different. Now, how can we go for permutation is, how are we going to arrange this for? That is, there are 4 prime numbers, but we need 3-digit numbers, so 4p3. 4 factorial by 4 factorial minus 3 factorial. That is 4 factorial by 4 minus 3 factorial, that is 24. 4 factorial by 4 minus 3 in the sense 1 factorial, that is nothing but 1. 4 factorial means 4 into 3 into 2 into 1, that is 24. There are 24 different ways of arranging these 4 prime numbers, 4 different distinct prime numbers to make 3 digits. That is question number 1. I think it is clear for all of you. There are 4 prime numbers, 2, 3, 5 and 7, and also we have to arrange, or we have to get only 3-digit numbers. For example, I have written here 2, 3 and 5, 2, 3 and 7, 2, 5 and 3, 2, 7 and 3, 2, 7 and 5, 2, 5 and 7. There are 6 ways with only single digit 2. Starting 2, we'll get 6 with starting 3. For example, 3, 2, 5, 3, 5, 2, 3, 7, 5, 3, 5. So in the same way, instead of 2, we have 3. That is 3, 3. Next, we are going with 5. We have again 6. With 7, we have 6. So 6 for each. With 2, we have 6. 3, we have 6. 5, we have 6. 7, we have 6. So 6 into 4, 24 different arrangements are possible. Let me go to the next question. How many different ways 4 cars are parked? 4 cars are parked in 5 different parking slots. So we have 4 cars and 5 different parking slots. So 5 is a bigger number, 4 is a smaller number. So we have 5 P4. That is 5 factorial by 5 minus 4 factorial, that is nothing but 5 factorial is 120. 5 minus 4 is 1 factorial. So 1 factorial is nothing but 1. So just for a glance for you, np0 is n factorial by n minus 0 factorial, that is 1. np1 means n factorial by n minus 1 whole factorial. So n factorial into n minus 1 factorial by n minus 1 factorial. That is, n factorial is really written as n into n minus 1 factorial. N minus 1 and n minus 1 we can cancel to get just n. npn equals factorial by n factorial, that is nothing but 0 factorial. 0 factorial is always equal to 1. Now 4p4, for example, is 4 factorial by 4 minus 4 factorial, that is 0 factorial, that is nothing but 4 factorial, because 0 factorial is equal to 1. Now let us see next question. There are 4 alphabets, A, B, C and D. How can you arrange these 4 alphabets in 3 different ways? How can you arrange the 4 different alphabets in 3 ways? Only 3 ways, but we have to arrange 4 letters. It's 4. Because the numerator in this is always more than the denominator, that is 3. We can take it like this for you to understand, in the sense 4 factorial by 4 minus 3 factorial, that is equal to the next one. 7 A, B, D, E, and E are there. There are 4 places. In how many ways you can arrange 7 A, C, D, E, F, G in 4 places? 3, 4. Now if you see here, that is 7 factorial by 7 minus 4 factorial, that is 7 factorial by 3 factorial will give the answer. Let us see, 7 factorial is 5040 by 3 factorial is 3 into 2, 6. That is 6 8 is 48, 6 4 is 24, 840 is the answer. Now just see, my dear students, 1 factorial is 1, 2 factorial is 2 into 1. 3 factorial is 3 into 2, 6. In the same way, we have to remember and by heart this. 4 factorial, 4 into 3 into 2 into 1. 4 3s are 12, 2 is 24. 5 factorial, 120. That is 4 factorial into 5, 120. 24 into 5. 6 factorial, 5 factorial into 6, that is 120 into 6, 720. 7 factorial, 720 into 7, that is 5040. So 1 factorial, 2 factorial, 3, 4, 5, 6, 7. If you remember up to 7 factorial, that is more than enough for you to solve any type of questions. Maximum number are based on this up to 7 factorial. Let's go to the next one. How many ways we can arrange letters of the word where vowels are always together? I'm going to different type of questions at a time, but I'm going to explain in the next video in a proper order. How many ways we can arrange the letters of the word where vowels are always together? The given word is learn. By seeing the word learn, we can tell E is a vowel, A is a vowel. There are two vowels, E and A. We can write the same as A and E also. That means there are 2 factorial ways to write these vowels. Vowels must be together. Now remaining words are L, R and N. So E, A can come here, E, A can come here, E, A can come here, E, A can come here. There are 4 places where the vowels are not moving, they are together. So 4 ways are there, that is 4 factorial ways into A must come once first or A must come first. Again it's a 2 factorial, that is 4 factorial into 2 factorial. 4 factorial, as you know, 24 into 2, that is 48 is the right answer. So the first question, how many ways we can arrange the letters of the word learn where vowels are together? I think it's clear. Why? Because there are, again I'm going to repeat it, there are spaces, let us see, that is L, R, N are there, remaining are vowels. Here they can come together, here they can come, here they can come, or here. So there are 4 different places, so 4 factorial into which ones come first, that is again 2 factorial. Next, in the same way, how many ways we can arrange the letters of the word where all the vowels come together? The word is attitude. Now let us describe 1, 2, 3, 4, 5, 6, 7, 8. There are 8 alphabets in the word attitude. In this, A is 1 vowel, I is 1 vowel, U is 1 vowel, E is 1 vowel. There are 4 vowels, A, I, U and E. All these 4 vowels is a single unit now because they are coming together. Now if you see here, how many remaining letters are T, 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 D, T, 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 T. Here all the vowels can come together, here or here or here or here. So 1, 2, 3, 4, 5 places are there where all the vowels can sit together as a single unit. So 5 factorial into A, E, U, I, or A, I, U, E, or U, A, I, E. Which is the first method of arranging this? They can be arranged in 4 factorial ways. That is 5 factorial, empty places, that 4 vowels are there. Now when repetitions are there, you can see T, T, T is repeated 3 times. Whenever you have repetitions, we go for the denominator and write like this: 5 factorial into 4 factorial by 3 factorial. Let's see in how many ways we can arrange the letters of the word where the vowels never together, where the vowels never come together. Now if you see this, how many ways are there where the vowels never come together? For example, let us take learn. So there is one method of solving. Vowels come together. If you subtract where vowels are coming together, then automatically, if you remove how many ways are there where all the vowels can sit together from the total number of ways, then the remaining is nothing but total number of ways minus number of ways where vowels are coming together. Finally you will get the ways where vowels never come together. Let us see the word learn. Here we have vowels, for example, ye, ye. Ye and a should not come together. So how many? The question is how many ways we can arrange the letters of the word learn where the vowels never come together. Now let us see what are the remaining L, R, N. So 1, 2, 3, 4 are the positions where vowels come together. 4 are the positions where vowels can come together. That is, EA can be here, EA can be here, EA can be here, or EA can be here. That is nothing but general we take 4 factorial into which is going to come first into 2 factorial, the actual arrangement. Total, if you see, learn 1, 2, 3, 4, 5. There are 5 letters or 5 alphabets. So 5 factorial is total 120. 120 is the total number of ways of arranging the alphabets learned. From this, now we are going to subtract the number of ways where the 2 vowels come together. Then we are going to get the answer where the vowels never come together. That is nothing but 4 factorial into 2 factorial, as I explained. That is 4 factorial, 4 3 is 12, 2 is 24, 24 into 2 is 48. I am going to subtract from 120. 120 is the total number of ways. From this 120 I am going to subtract 48 because these are the ways where the 2 vowels come together. So 120 minus 48 you are going to get 72. Let us see one more example from the word sister. You can try it first. In sister, how many ways are there where the 2 vowels, or not the 2 vowels, where all the vowels never come together? So first of all, what we are going to do is, what is the total number of possibilities of arranging the word sister? 1, 2, 3, 4, 5, 6. That is nothing but 6 factorial ways. In this 6 factorial, if we remove or subtract the number of ways where vowels come together, then automatically the remaining will be vowels not coming together. If we subtract vowels all together from total number of ways, then the result will be the number of ways of arranging where vowels never come together. Now let us see here. Total number of ways is there are yes, I, yes, T. Here there are 6 factorial ways. From the 6 factorial ways, okay, one more thing, repetitions are there, 2 yeses are there, so automatically divided by 2 factorial. This is the total number of ways in the sister. Why? Because yes is repeating, first yes must come or second yes must come, there is no clarity in this. This is the total number of ways. From this total number of example 6 factorial, that is 5 factorial is 120 into 6 is 720 divided by 2, that is nothing but 360. Total ways are there. From this, vowels coming together, there are 2 vowels, I and E. Vowels coming together, let us check. Now, yes, yes, T, R, 1, 2, 3, 4, 5. There are 5 ways where vowels can come together. So 5 factorial into how many vowels are there? I and E, 2 vowels, so into 2 factorial. Okay. Divided by 2 factorial. Again, why? Because S is repeating. So the final answer, if you just check, vowels coming together is 5 factorial into 2 factorial by 2 factorial. And also vowels total number of ways is 6 factorial by 2 factorial. That is 360 minus 5 factorial 120. 240 ways are there where we can arrange the alphabets of the word sister where vowels are never together. Now we are going for the next question. Same type of questions. How many ways we can arrange the letters of the word, the alphabets in a word learn where consonants never come together? How many ways we can arrange the alphabets in the word learn where consonants never come together? Instead of vowels we have consonants. What are the consonants? Let us see. L, R, N, L, R, N, E, A are vowels. So what we are going to do, consonants must not come together. Now consonants coming together, if we subtract from the total consonants coming together, then automatically we are going to get where the consonants never come together. So let us see the total number of ways of arranging these 5 alphabets. 1 2 3 4 5, that is nothing but 5 factorial. The first step, that is consonants coming together. Yes, 1 2 3 4, that is E dash. Here we have, here we can get LRN, here we can get LRN, here we can get LRN. So automatically 3 factorial into 3 factorial ways. As you know, L must come first, or R must come first, or N must come first. So 5 factorial is the total for learn, minus 3 factorial into 3 factorial. We're going to subtract 120 minus 3 factorial is 6 into 6, that is 36. If you subtract, we're going to get 84. That's the final answer, my students. Now we are going for the next question. How many ways we can arrange the letters of the word attitude so that vowels occupy only odd position? All of you know the vowels A, E, I, O, U. In this question, how many ways we can arrange the letters of the word attitude so that vowels occupy only odd position? So first of all, there are many things for us to know. How many letters are there in this word? A, P, T, I, T, U, D, E, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. There are 8 different letters. Or alphabets, you can call it as alphabets too. Now 1, 2, 3, 4, 5, 6, 7, 8 positions I have drawn here. Now we must get the vowels only in odd position. Odd positions are 1, 3, 5 and 7. So there are 4 different odd positions in this 8th letter. So 4, there are odd positions. We have 4 vowels too. What are the vowels in the question is A, I, U and E. So we have here, I have written A, I, U and E are the 4 vowels. So 4, P4, that is nothing but 4 factorial by 1, that is nothing but 4 factorial ways. Now coming to the remaining are P, T, T and D. Again in the same way, 4 factorial, we have the remaining consonants out of these 8 positions, or also here T is repeating, so automatically by 2 factorial I'm going to take it. So that is 24 by 2, that is 12 ways we can get it. Okay, 4P4 into 12, that is 4P4 into 4 factorial by 2 factorial will give the answer. This is about odd positions. Same question, how many different ways do we get the attitude word can be arranged such that vowels occupy even positions only? Here we can see vowels must occupy even positions. Even or not, that doesn't matter. We have again A, P, T, I, T, U, D, E, 1, 2, 3, 4, 5, 6, 7 and 8. 8 alphabets are there in this. 1, 2, 3, 4, 5, 6, 7 and 8. In these 8 places, vowels, let us check. That is, A is a vowel, I is a vowel, U is a vowel, E. There are 4 vowels as we already know it. So, how to arrange in even places? 2, 4, 6 and 8. Again 4 vowels. We have 4 places. Remaining are P, T, T, D, which are not vowels. So 4 factorial by 2 factorial is the remaining. Coming to this, 4 factorial, that is for vowels, by 2 factorial, that is 12 ways. It is actually the same answer. Why? Because for even or odd, we have the same for even and for odd positions. Let's go to the next question. In how many ways the word fridge? F-R-I-D-G. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. We have 6 alphabets. Be arranged so that no 2 vowels come together. Vowels must not come together. Vowels must not come together. Now let us see this. Now vowels are I, ye, I-N, ye. Vowels must not come together, that is F, R, D, G are the general letters. Vowels are 1, 2, 3, 4, 5. There are 5 different places for arranging the vowels. F, R, D, G. Here vowels coming together, here vowels coming together, here vowels coming together, here vowels. So from total, if I subtract these vowels coming together, then automatically I will be left with no two vowels come together. That is nothing but 1, 2, 3, 4, 5. There are 5 positions, that is 5P2. Why? Because we have only 2 vowels here, I and E. So the 5 places 2 vowels must be arranged. And the remaining is nothing but 4 factorial ways we can arrange. That gives answer. If we want 5P2 means 5 factorial by 5 minus 2 factorial into 4 factorial, 5 factorial by 3 factorial into 4 factorial. 5 factorial 120 by 3 factorial 6 into 24. It is 4 times 480 will be the answer. Let's go to the next question. How many ways the word fridge can be arranged such that no two vowels are together? No two vowels are together. Now, how many ways the word fridge can be arranged such that no two vowels are together? Now, if we just take vowels, there are I and E here in the same. There are 2 vowels. There are 6 places. 1, 2, 3, 4, 5, 6. 6 places are there for 6 alphabets. That is, again, we have F, R, D, G, which are not vowels. That is 1, F, R, D, G. Here 2 vowels can come. Here, that is 5. We have 2 vowels out of 5 places, 5P2 into the remaining of 4 factorial, that is 5 factorial by 3 factorial into 4 factorial. As we discussed, it is nothing but 480. Now the next one, same type. How many words or how many ways the word places can be arranged where the no two vowels are together? Here also the same. We have A and E as the 2 places, and dash, P, L, C, S are the 4. Then 5P2, that is 5P2 in the sense there are 5 places for the vowels to come together, but we don't want that into 4 factorial. If we just take the remaining 5P2 into 4 factorial will give the required answer. So what we have done in the previous, let us recap for now. What is meant by permutation? It's nothing but arrangement